Good afternoon, everybody. If you can take your seats, we'll get today's meeting started. So welcome to the June 2015 CVRS Alberta meeting. My name is Gerry, and this came out of a necessity of this battery eliminator project I've been working on for the past year for transocean radios and their clones. Simply because the batteries, the original batteries for these, apparently according to the internet, were last manufactured in 1969. And although it's a standard case size from that time, there were no standard case sizes available from anywhere in the standard conventional materials that we've come to use for electronic cases. And here are some of the materials that could be used to make a case for your electronics projects. Wood. In fact, the replacement battery pack that's in that Transocean right now is made out of 1/8 of an inch thick wood from Gerry, one of our former members who's now out on Vancouver Island. Of course, we're all familiar with the metal cases we can buy in various sizes, and that can be steel or aluminum. Again, I'll talk about the advantages and disadvantages of metal cases. I started looking and doing some research on using plastic materials to make my own cases, and that's what we have here today. And basically, if I can do it, anybody can do it. Glass, and I was able to figure out what I can do for dimensions, and I was able to cut the plastic and glue it together. The only specialty item and tools you need is you do need a saw blade. You can actually get these. I got mine at Rona. It's now a Rona, but it used to be Totem, yes. And you can actually buy an 80-tooth saw blade. And it actually has written on it, designed for metal and plastic cutting. So you can actually buy these blades. I got mine for about $50, so considering I already had a table saw, and I already had something I could put the blade into and use and get a fairly accurate and decent cut, the saw blade was actually a minor expense. The glue, or the solvent that's used to glue the pieces together, is what's called methyl chloride. So this is the fast set stuff. It's fairly, as you can see, it's fairly liquid. It almost reminds you of water. And you do need a small applicator bottle, which looks like a hypodermic needle. And again, this was about, if I remember, $20–30, and the applicator bottle was about $4. But again, the amount of solvent, or the amount of methyl chloride I used to make this case, is a fairly, this will go a long way. You can make a lot of plastic cases with this stuff. Pierre had an interesting question about cutting the plastic on the saw. The interesting thing is, when you cut the plastic, you're not really cutting it like you would, say, a piece of wood or a piece of metal. You're actually melting the plastic. What's happening is, because you've got 80 teeth on the blade, and it's usually a 10-inch saw blade, spinning at a high RPM. Basically, every time the tooth cuts in, it starts to tear at the plastic, but there's enough cuts coming where you're actually melting the plastic. As you're cutting this plastic on the saw, you can actually see it melt as you're cutting the plastic. But there's some tricks to that. The first thing is, you want to set the blade height so it just clears the work. If you set the blade too high, what happens then, and I did this once, is it will actually shatter the work. The work will shatter if the blade is set too high. So you want to set the blade where it's just clearing your work. The other trick is the feed speed for the plastic. This is one of these things where you can't be in a rush. Because again, haste makes waste. The stuff will shatter. or you don't get a smooth cut. But what I found is about 1/4 of an inch per second of feed speed will guarantee you a nice, clean, straight cut. And later on during our break, you can come up and take a look at this case. What this does is gives you a really nice cut. One of the other issues that as you're cutting, you are going to get plastic flying. So when you cut wood, you get sawdust. When you cut metal, you get metal filings. When you cut plastic, you get these little thin things that fly around. They tend to be a little on the hot side. They also tend to be fairly sharp. So because of that, you do need, this is the safety equipment I recommend you have when you're cutting the plastic. So you do want goggles over your eyes, or safety glasses with the foam back. Because these filings, they get into your eyes. If anything, they're going to be quite the irritant. And some of those filings can be fairly small or fairly large. What I recommend is a dust mask over your nose and mouth, because again, this does create a little bit of plastic dust. This stuff can be a bit of an irritant, so I'd recommend sleeves. And nowadays you can buy what's called Kevlar type gloves. Our electricians use them so that when they're cutting with X-Acto knives, they can't slice their fingers open. You use all those combinations, you're going to be able to run this plastic through the saw all day long, and you'll still be relatively comfortable, but you're also going to eliminate any exposure to dust, flying hazards, or anything else that might be associated with the plastic. One of the other tricks to this is drilling. So what I use on my drill press is I use the slowest drilling speed with the sharpest bits, but as I'm feeding the work down, feed it slowly. Because again, if you, especially with the larger bits, if you're feeding the work too fast, it will grab the work and spin it around. And typically, if you've got the work fairly well clamped, you'll break the plastic. So again, this is something you can't be in a rush to do. Slow speed feeds. And on this case, for example, what I was able to do for here is use my step bit, and I was actually able to slowly drill this hole out and enlarge it. This took about 3 minutes to drill out. In fact, before I even glued this side on, what I did is I marked out everything, made sure all these holes were drilled, made sure everything would fit, and then I finally glued this side onto the box. So that is the other trick too, is if you have to drill any holes into the side for wires, plugs, switches, lights, accessories, do it while the plastic piece is still on its own. Mark it out, drill it out on your drill press, get it all cleaned up, and then finally glue it down with the methyl chloride. And that's the next step. After everything is cut and drilled, you can now start to mount everything together. And typically, all I simply did is I just put the two pieces together. And with the methyl chloride, I just ran a small bead of liquid along the crack and let it seal. And per the can here, the setting time is approximately 1 to 2 minutes, or for working time. Fixture time is 3 minutes, and 80% bond strength in 72 hours. So you've got the luxury of time of putting this stuff together, but then you need to let it set for 72 hours or 3 days before you can do anything else with it. So again, it's one of those things, take your time. The interesting thing about the methyl chloride is some people might be tempted not to use the applicator bottle and just say, well, I'm just going to open up this can, use a brush, and brush it on. This stuff's like, what was the slogan for Grill Cream? Little dab will do you. That's exactly what this stuff is. You don't need a lot of methyl chloride to actually create the reaction to bond the acrylic pieces together. So spend the $4 on the applicator bottle. And I had a hard time pouring this into the applicator bottle, so if you've got something like a pipette or a clean glass squeeze bottle, siphon it out and then siphon it into the bottle and do your transfer that way. Because I asked the guy at the plastic shop, well, how do I transfer it? He says, oh, just pour it. The problem with pouring it though is that with this wide mouth, you're still going to end up with some spillage. The stuff does evaporate, but again, I would recommend no smoking or open flames while you're doing it. Use a fairly well ventilated area with the applicator and you'll be fine.
Isn't that stuff a carcinogen?
No, I've got the MSDS data sheet for it, and I didn't see anything like that at all.
Okay. I
But-
don't have to be well ventilated, it's nasty stuff.
Well, when you smell it, it's got an aromatic, it's got a smell to it. Like you gave it a little bit of a whiff, and I thought, yeah. But the neat thing is that after it's reacted to the plastic, and then it's fine. Everything is good. So it's the typical thing. The processes we use to get the finished product, which is safe to use, can be hazardous, and it's a matter of knowing the hazards, and you're 100% correct there, Radar. So that's the gluing of it. There's many suppliers in Edmonton, but the supplier I used, if I remember correctly, is PG Plastics, just off 51st Avenue. And what they did is they actually gave me a pile of plastic cast-off acrylic sheeting. And as you can see, this stuff is pretty flexible. Once you glue it and glue it all together and make a composite structure out of it, it's actually quite strong. But I got a bunch of these cast-offs for about 35 bucks. But the other neat thing is, if clear plastic doesn't float your boat, one of the things you can do is there are spray paints out there that really love acrylic, and you can paint these cases to whatever color you want, whatever finish you want. So if you want to pimp this out with some sort of fancy colors and then finish it off with some hand-painted graphics or logos, you've certainly got the flexibility using a plastic case in this scenario. And of course, for square holes like I did here, I just simply drilled it out and then used a triangular file just to straighten the holes back out. One other secret to cutting the plastic as well too is that if you don't have a good fence on your saw, I certainly don't. I've got an old Delta saw where the fence came with the saw, and it's maybe accurate to within a 1/16 of an inch. Not good enough for what we're doing here. You want to cut the plastic freehand. So what I typically do is I'll mark both ends here with an indelible ink marker. And then I'll put on something like a finishing masking tape to both sides. Now I've got an edge that I can visually see the saw blade cut against. But there is a trick to this. You want to put the masking tape on the finished side of your work. So if you're cutting something that's this size by this length, and this is the cutoff, this is the cast off that's going to go into the recycle bin, you want to make sure the masking tape is on the finished side of your work. Feed that through your saw. The other hint I forgot to mention earlier as well too is that if you're feeding, how can you tell if you're feeding the work in too quickly? What will happen is as the plastic melts, is it'll start to ball up on the bottom side of your work. And then what happens is that as you're feeding the work through, so you've got your saw blade coming up through the table, and you're feeding your work through like this. What happens is that as it balls up, that ball will stick to the bottom of your plastic, and once you get past here, it'll actually start to collect under here, and eventually it'll bind your work. So your work will jam. So as soon as you start to see the plastic ball up, that's when you want to back off your feed speed. I found 1/4 inch per second is sufficient. But again, that's for this type of plastic, this thick. So what you might want to do for the first couple of cuts is, again, take your one small cast-off piece, feed it through your saw, and just get a feel for how high should the blade be set and how fast can I feed it through. But again, don't be in a hurry. Don't be in a hurry to make one of these things. Someone says, I want one in 5 minutes. Tell them 3 days.
I use a big bandsaw, works like a charm.
Bandsaw?
Yeah.
Okay.
What about a jigsaw?
I think it would be a little too flimsy for the blade.
Yeah.
It's the same thing, if that blade, as soon as it generates the heat, get the melting. I've tried some of that, and if you just push it, you end up with a big ball and it's all glued together and that blade is stuck in the plastic.
Yeah.
It just puddles up.
What you'll find on this piece is that I did cut this edge on the saw, and there is a couple of ridges of plastic that did build up. Most of these just flick off. You just flick it off, but you've got a couple of stubborn ridges here. But again, you just take a fine-tooth triangular file, couple of quick swipes, and you've got yourself nice clean corners, so that when you're setting it down right there and you're running your glue, it's done. It's done, it's quick, it's fast. If you're concerned about squaring your work, what I would do is take a decent 2x4, something without a lot of knots and tangles and stuff in it. And use that to block your work. So that this would be the outside, your other plastic piece would be along here on the inside, on your table. Everything's nice and square. Then take your applicator, run it through, and hold it for about 1 to 2 minutes. After that, let it set, and then let it bond. So it is a chemical bonding process, but it's not a fast process. It isn't like crazy glue where, how did that crazy glue work? You put on 2 drops, put it together, and you almost got an instant bond depending on your material. This isn't as fast as crazy glue. But keeping in mind what you can do with it for our electronic stuff, it's got more than 1,001 uses. Some good comments here. Any other questions or comments?
If I don't really right now have the equipment, so I just have a jigsaw, and I'm wondering if that's good enough.
You'd have to go slow.
Yeah.
If you push it, it just puddles out.
Not
I would
only-
almost mount that, like if you can, mount the actual jigsaw underneath.
Or-
Still have your blade up, like a regular saw. Okay, so you have your piece of wood,
Okay.
okay? Mount your jig underneath, have your blade up top, and use it slowly that way. That way your blade is stable, and you're not jiggling with it with the jigsaw.
Poor man's bandsaw.
Yeah.
Because I think a bandsaw would probably cost $200 or $300.
Yeah.
Oh, yeah.
The other
yeah.
thing you could do, Dave, let's say this is the work you want to cut and this is your tabletop surface. Get a couple of clamps, clamp it down really, really tight, and then feed the jigsaw through. I've got one of these jigsaws at home, but you really need a good fine-tooth blade, and as Radar said, slow.
Yeah, it is.
If you described it as a razor blade, would it break like glass or not?
I thought about that, and I hadn't tried it, but I think the short answer, Bill, would be no, because when you're trying to break glass, your glass is pretty rigid, and the result is it's pretty brittle, so when you score a line, you've now broken the crystal structure where it cleaves quite easily. When you see how flexible this is, even if you were to score it, I don't think you'd break it easily. Or
Yeah.
put it this way, you wouldn't get a clean break.
That would be very big.
So,
I think it's directly proportional. If you didn't want it to break, let's say the screw hole, that's where it's going to break.
yeah.
And you couldn't, and if you take that, try to beat the snot out of it, it's indestructible unless you don't want
Yeah.
that screw hole or something to break, yeah, then it will.
The only way I've destroyed plastic, and I had a couple of cuts go south on me, is feeding the drill bit into the work too quickly,
Yeah.
especially the big 1/2-inch bit,
Yeah.
and running it too quickly through the table saw. Because the piece will shatter and go flying all over it turns into shrapnel when it goes flying off your cutting table. So again, it's one of those things, have the safety equipment and just take your time. These things are a labor of love. Yes, Radar?
Yeah, the other thing I've noticed at work is it may not be acrylic, but you can drill and tap and
Yep.
type of thing, and that's, you know, if you're good at precision drilling and you can drill little things in it to be mounted. Covers just like you with wood, only like 1032, 632s.
Yes.
We use that with a different type of plastic all the time, but
Well, actually, I did talk to the guys at the plastic shop, and they claim that this stuff does tap nicely.
So approximately how much did that cost to make?
With the materials that I bought and the glue, estimate, just for materials alone, under 10 bucks. I'm gonna say about closer to $6 or $7 based on square footage usage. And the fact that you're gonna have a little bit of waste. You're gonna have little thin pieces that come off the table saw when you're done. And in terms of labor, this took probably about, the gluing itself took less than an hour to do. Most of the labor went into drilling the finishing holes. But again, what I did is I took my printed circuit board program, spun out where all the holes were, laid that down here, and used that as a drilling template for all my holes. And then that's what, and then I just drilled out this flat piece on the drill press. Once I did a trial fit and everything worked, then I glued it on down onto the sides and the bottom.